So in the last video, I had discussed about this 12th question. So now coming to the 13A question, and in second part, A question is also theory question, and coming to the problematic part. This was the question given. An ideal 25 kVA transformer has 500 turns on the primary winding and 40 turns on the secondary winding. 40 turns on the secondary winding. Primary is connected to 3000 volts 50 Hz supply. Determine primary EMF, secondary EMF, and maximum core flux. So this is 40 turns, primary winding and secondary. First, let us write the given data. KVA rating of the transformer is given. That is 25 kVA. That means 25 into 10 cube volt amperes. So it has 500 turns on primary winding. That means number of primary winding turns N1 is equal to 500. And secondary winding turns are also given, that is N2, that is equal to 40 turns. And primary is connected to 3000 volts, means E1 is equal to 3000 volts. This is 50 Hz supply. And frequency is also given, F is equal to 50 Hz supply. So what you have to find out, the primary EMF. So actually the primary is connected to 3000 volts. This is V1 or E1. So directly the first one, a primary EMF is 3000 volts. As it is an ideal transformer, always V1 is equal to E1. it is mentioned in the problem, the transformer is a ideal transformer. So V1 is equal to E1. The primary EMF is over. Next, the second one, secondary EMF. So you need to find out E2. The transformer EMF equation, E2 is equal to 4.44 F N2 phi m. So in this equation, we know the frequency, number of turns, and we don't know the flux. So we cannot use this formula to find out the induced EMF in the secondary. So what is the other formula? We know the E1 value, N1 and N2. So we have a relation of induced EMF and number of turns. E2 by E1 is equal to N2 by N1, voltage ratio. Voltage ratio is equal to turns ratio. So E2 by E1 is equal to N2 by N1. In this, only E2 is the unknown thing. So substitute all the values. E2 is equal to N2 by N1 into E1. N2 value is 40 divided by N1 value 500 into E1 value 3000. So 240 volts is the secondary induced EMF. Next, maximum core flux. The third one you have to find out maximum core flux. That means phi m you have to find out. So from the EMF equation, E2 is equal to 4.44 F N2 phi m. Either secondary induced EMF you can use, or primary induced EMF also you can use this equation. E1 is equal to 4.44 F N1 phi m. In the two cases, the flux is same. So we can use any one formula. Then phi m is equal to E2 by 4.44 into F into N2. E2 value how much we got? 240 volts. 240 divided by 4.44 into 50 into number of secondary turns 40. So by solving this, you can get the maximum flux. So this problem is over. So next problem, 14th question, and second one B bit. So remaining two are the theory questions. So this is the problem. A 4-pole 3-phase 50H induction motor runs at a speed of 1470 rpm speed. Find the frequency of the induced EMF in the rotor under this condition. The number of poles are given, that is 4 pole. Phase, it is 3 phase. Frequency is given 50H, and the motor runs at a speed of 1470 rpm. So motor is running at a speed is nothing but it is the rotor speed, Nr. So Nr is equal to 1470 rpm. So what you have to find? Find the frequency of the induced EMF in the rotor. So EFR you have to find out frequency. You have to find out the frequency for what? For the rotor induced EMF. So first write down the given data. Next, 14th question. Given number of poles. Number of poles. P is equal to 4. Always poles will be denoted with the letter P. And it is a three-phase system, and rotor speed is given. Motor runs at a speed that is nothing but rotor speed. So it is Nr. Nr is equal to 1470 rpm. and frequency is also given, that is 50 Hz. If frequency is not mentioned in the problem, you can take it as 50 Hz. In India, the frequency, supply frequency is 50 Hz, so you can take it as 50. Then what you have to find out? A rotor frequency. Frequency of the rotor induced EMF you have to find out. And this will become a stator frequency. So there is a formula for the frequency of the induced EMF in rotor. Fr is equal to S into Fs. S times the stator frequency. Here S means slip of the induction motor. S is the slip of the induction motor. Now how can you find out this slip? Slip formula S is equal to Ns minus Nr by Ns. Here Ns is the synchronous speed and Nr is the rotor speed. Rotor speed is given, but we don't know about this synchronous speed. So find out the synchronous speed. Synchronous speed formula Ns is equal to 120 F by P. So 120 into frequency is 50 Hz and number of poles are 4. So it is 1500 RPM. So synchronous speed or stator speed is 1500 RPM. So substitute that 1500 minus 1470 divided by 1500. You will get the slip value. So 30 divided by 1500. You will get it as 0.02. The slip value is 0.02. Therefore, rotor frequency is equal to S into Fs. S value is 0.02 and frequency is 50. So 2 by 100 into 50. So you will get as 1 Hz. So rotor frequency. So frequency of the induced EMF in rotor is equal to 1 Hz. So first you have to know the relation between the rotor induced EMF frequency and stator induced EMF frequency. So under running condition, the induced EMF in rotor has a frequency Fr and that is equal to slip times the induced EMF in the stator. So that's it, this problem. Next one, in 15th question. So there is again a problem in a 4-pole 3-phase alternator. The number of poles are given. Armature has 36 slots. The number of slots are given. Armature winding will be placed always in the slots. So how many slots are there for the armature? Total 36 slots are there. And it is using an armature winding which is short pitched by 1 slot. Determine its coil span factor. So armature winding, how it is? So there is a type of winding: armature winding, short pitch winding, and full pitch winding. So so here the type of winding is short pitch. So how it is short pitch? By 1 slot. So you have to find out its coil span factor. Let's see this problem. Next, 15th question. See, in a machine, there will be number of poles. Suppose here, let us assume, for example, 2 poles are there. First, you should have an idea of what is meant by short pitch winding. So I have a machine that has the 2 poles. Under each pole, some slots will be there. Under North Pole, 4 slots, and under South Pole, 4 slots are there. So total, how many slots are there? 8 slots. A 2-pole machine which consists of 8 slots. So under each pole, the slots will be divided like this. Now the armature winding will be placed in the slots. Suppose under north pole, one end of the winding is placed under north pole and other end is placed under south pole. And in one more case, one end of the winding is placed under north pole and other end is also placed under north pole. Position first, this one. So this is one type of winding. So how it is placed? The one end of the winding is placed under one pole, first slot, and other end of the winding is placed under the next pole, first slot. So that means two identical slots. Here under north pole first slot and here also under south pole first slot. So the winding two ends are placed under same slots, identical slots in the two consecutive poles. So this type of winding is called full pitch winding. Suppose if under north pole, let us assume south pole, so number of slots, again I'm taking the same slots. One end of the winding is placed under first pole, under north pole first slot, and other end of the winding is placed under north pole again. One end of the winding is placed in first slot under north pole and other end of the winding is also placed under the north pole only in fourth slot. So in this case, this type of winding is called short pitch winding. So it is not the full pitch winding. So this winding is called as short pitch winding. The total winding is placed under the same pole. So that indicates a short pitch winding. So how much it is short pitch from the full pitch? So in the above case, where it has to place other end of the winding under south pole first slot. Suppose in north pole, if you place under the second slot, one end of the winding, if you place under the second slot, then other end of the winding must be placed under the south pole second slot. So under identical slots you have to place. So then it is called the full pitch winding. So under first pole, so under north pole first slot one end is placed. So it has to place under the south pole first slot. Then it will become full pitch. So how many slots it is less from the full pitch? One slot. So one slot short pitched slot or short pitched by one slot. So this is the meaning. Short pitched by one slot is nothing but. So in this case, the winding is short pitched by one slot. So in the above problem also, it is given the winding is short pitched by one slot. So how many poles are there in the above problem? There are number of poles 4 and number of slots 36. So number of slots 36 means under each pole how many slots will be there? 36 by 4, 9 slots. So under each pole there will be 9 slots. The number of slots per pole. Number of slots per pole. It is indicated with n. Number of slots per pole n is equal to 36 by number of poles how many? 4. So that is equal to 9. So number of slots per pole n is equal to 9. So what we have to find? The winding is short pitched by one slot. It is given winding is short pitched by one slot, and you have to find out coil span factor. So this coil span factor is also called as pitch factor, that is indicated with Kp. Kp is equal to cos alpha by 2. This is the formula, cos alpha by 2. Here alpha is nothing but short pitch angle. Alpha is nothing but short pitch angle. But short pitch angle is not given. The winding is short pitched by one slot is given. So then how can you find out the short pitch angle? If you know one slot angle, then that will be your short pitch angle. Why? Because the winding is short pitched by one slot. So if you know one slot angle, that will be your alpha. Suppose if the winding is short pitched by two slots, then find out the angle for find out the angle for two slots. And how can you find out the slot angle? So there is a formula for slot angle. Slot angle is equal to 180 degrees divided by n. So slot angle is indicated with beta. 180 divided by n. N we got it as 9. So 180 by 9. It is 20 degrees. So each slot angle is 20 degrees. Suppose if the winding is short pitched by two slots, then how much will be the alpha value? 2 into 20, 40 degrees. So here the winding is short pitched by only one slot, therefore alpha value is equal to 20 degrees. So remember this, here beta I wrote it as 20, and again I am writing alpha is equal to 20. Why? Because the winding is short pitched by only one slot. So one slot angle we got it as 20. So that's why alpha is equal to 20. So then coil span factor Kp is equal to cos alpha by 2, means 20 by 2. It is cos 10 degrees. What is the value of cos 10? Cos 10 is 0.98. So this is coil span factor. That's it. I hope you understand. Practice the problems, otherwise you cannot do the problems. So by this question paper is over. 2019 regular question paper, this one. So most of the questions are problems in this. In each and every question, one bit is a problem. If you see the question paper, A and B questions are there. Suppose if A is a theory question, B bit is a problem. See, this is 12A. A bit is a theory question, B problem. In 2A also, 2A is a theory question, B is a problem. So in 13, again there is a problem. So that's why don't neglect the problem. So this question paper is over. I will come with the next previous question paper.